So, good evening, everybody. Thank you for joining me. My name is Ken Rosenthal. I'm a park naturalist at Gulf Branch Nature Center, and I love birds. And I hope to give you guys some interesting things to think about with bird migration. It's one of those things I think we learn about early on, but there's some information that's out there, just like everything else. There's some information that you learn early on, and it kind of gets embedded in there. And there's parts of it that are true, and the parts of it are not. And I want to unravel some of that. Sometimes I feel like some with our science education, we learn some things early on, and then there's never the nuances don't get added to it. And so bird migration is one of these things that's just to me, it's absolutely fantastic. It's amazing. But there's a lot of really neat things in there. So I want to remind you again, I am recording this. If you have any questions and it's something that's really in the moment, please interrupt me. I'm not able to look at the chat while I'm in here. Although if you put something in the chat, I will definitely check at the end to see what's in there as far as questions. But if you raise your hand and put something in the chat and you need that answer right away, I'm probably not going to notice it. So it really helps if you politely be like, "Hey Ken, I got a question about that." I have no problem with that. I'd rather answer that question in the moment so it has its best impact. So let me go ahead and I'm going to share my screen. No, 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 no. And we'll get started. No, screen. Thank you. All right. There we go. All right. So deep dive bird migration. We are going to talk about birds migrating. I went for the definition of this one because it's a really, really tough definition. It's animals moving from one area to another. This can be generational. This can be one way. But when we're talking about bird migration, it's typically there and back. So there is a return trip as well as obviously the departure. It's important to note that birds are not the only migrators. There are mammals that migrate. Some pretty long ones. The migration of wildebeest in Africa is pretty fantastic. Locally, we have several amphibian species that migrate from where they've been sheltering during the winter to breeding grounds to breed early in. The wood frog and the spotted salamander are pictured here. And then there are insects that do generational breeding. Monarch butterfly hope, most people recognize on the left, and the common green darner, which is a dragonfly on the right. There are several species of butterfly and dragonfly that do migrate. Um, and there's even some really small critters. This is Daphne, which is a small zooplankton that you can find in a lot of local waters. And they do a diurnal and nocturnal migration in the water column, staying low when it's bright out to avoid predation by fish and moving up to eat phytoplankton that are closer to the surface that need that sunlight during the day, and they're a little bit safer at night because it's harder to see. And so any of the fish, especially that are sight predators, it's much more difficult for them to spot the Daphnia in the water column at night when it's darker. I can talk more about these, and I will next month in the non-avian migration deep dive. A little plug there. But let's stick with birds. Bird migration is the one truly unifying natural phenomenon in the world, stitching the continents together in a way that even the great weather systems, which roar out from the poles but fizzle at the equator, fail to do. It is an enormously complex subject, perhaps the most compelling drama in all of natural history. If you've never read Scott Wiedensaul, I recommend him. He's definitely got a passion about birds. He's also got quite the talent with writing, and he writes some really, really interesting books and articles about birds, and so I recommend it. And I think he's right. I probably say this every deep dive. I'm like, there's more to it, and don't stop with this one here. There's a lot of really interesting information out there, migration that just 2 centuries ago, wasn't really there. Um, our historical knowledge of bird migration is very much weighted to recent years. There is evidence that Micronesians and Polynesians, in their traditional land finding techniques, knew to follow bird movements, to pay attention to where the birds were going and how the birds were flying, and that could help them, locate land while they're out there on the open ocean. And this is something that's, from a couple thousand years ago. Okay, so that information was there at the same time as someone like Aristotle might talk about certain birds and how they seem to fly away and they seem to come back at certain times. Larger birds like pelicans or storks, they also were these learned thinkers were also writing about how birds like swallows would hibernate in the mud at the bottom of a pond. And I am not kidding about that. This is a woodcut showing two men pulling a net full of, you can see there's a couple fish, there's a fish in there towards the bottom, but the other individuals there are all swallows, as if they threw this net into this waterway and pulled up not just fish from the bottom, but also swallows that have been hibernating in the mud. I think most of us would recognize that this is incorrect. But at the time, these were birds that lived in and around watery areas because there's a lot of insects that would emerge, and that's what they fed on. Swallows being very, very fast flyers, and they feed on a lot of insects while they're on the wing. And so this was a conclusion some people made. The birds disappeared, and so they were, I guess, to some extent aware of hibernation and animals sleeping during the winter. So they just assumed the birds were doing the same thing. And since they didn't find the birds, maybe they did it under the water in the muck, where they weren't going to be found by us because we don't mess around in the icy water in the winter. Excuse me. By the end of the 18th century, a more factual understanding of bird migration and where the birds was coming out. This is a history of British birds, which I think the original edition was 1797. Thomas Bewick is one of the writers of this book, and he talks about how he has a firsthand account from a captain of a ship who sees thousands of swallows flying over the ocean, and recognizing that this gentleman recognizing that this is probably means that the swallows go somewhere else and that they don't swim or they don't end up under the pond. And again, it's interesting to read this because it's always a secondhand account, especially the birds that are under the water for the winter. It's always a secondhand account. It's someone I know told me about someone they know that saw these birds under the water, and it was never a firsthand account, which obviously because it didn't really happen. But by the 1800s now we're getting a much better understanding of this. And I think this is fantastic. This is a field stork, and it's German for arrow stork. And this stork was found with an arrow in its neck in Mecklenburg. I think they call it county or territory in Germany in 1822. And this arrow that you're looking at is of African origin. So this bird was flying over Africa when it took this arrow in its neck and still managed to make it to Europe, which is impressive for the stork. But I can also only imagine that whoever the hunter was that hit that bird was thinking, what else can I do? I hit it in the neck and this thing still flew away. And I think there's been about 25 of these that have been uncovered since then, but this lent credence to the idea that these birds weren't just changing their form or hibernating somewhere local, but they were going to another place in the world and then coming back. This is the beginning of a much better understanding of avian migration. We now know that about 2 of every 5 bird species are migratory. It's a lot of birds that use this behavior, use this technique to survive really, really tough times or to leave an area before it becomes less desirable or less survivable. It's harder than I thought it would be. This is a great animation if you haven't seen it yet. And I know I sent this out to a lot of people when I first saw it because I was just gaga about it. It's from the Cornell Lab of Ornithology. They run the website called eBird. eBird is a way for birders to record their bird sightings. They have an app, or you can do it online if you take a paper list and you come home and then you want to do it online or whatever. They use this information to pay attention to populations, numbers, and frequency and where these birds are seen. But they've done it for so many years, and you can go in and put in old things. So it doesn't have to be just from now or later. You can put stuff in from 20, 30 years ago if you have those bird lists. And what they've accrued is an incredible amount of data that you just couldn't get if you were like a team of scientists. This is hundreds, thousands, I'm sorry, it's got to be thousands of people around the world entering information into this database. And so one of the things that they've been able to do is create these animations showing a bird species move through its year, where the abundance is. And what this is showing here is these are actually, each of these dots is an individual species of bird. It's an average of where all the birds are, but it's showing the movement of 118 different species of birds throughout the year. So if you check the colors against the key to the bottom left, you'll see that they'll start out dark blue, and that's January. here's where these species are in January, and here's where they move. And they're going to move and change. By the time they hit green, we're at midsummer, and then by the time they get to red, we're at the end of the calendar year. And you can see there's a lot of move, and there's movement laterally, not just north and south. And then at some point here, we hit the summer into fall, and boom, they all go back to where they started when they were dark blue. And again, each of these dots represents a species. So there's thousands, maybe hundreds of thousands of birds of each of those species moving through all this. Just imagine the massive amounts of birds moving back and forth between these continents, and they do this every year. Question? Oh, okay. So why move? What is the impetus? What is the importance for these birds to leave where they are now to move somewhere else? Why specifically? I could just say, why would they leave Virginia to go to the tropics? I think we can all have some ideas on that. But for a bird, because there are risks involved, and we'll talk about that too. For a bird, why migrate? There's the availability of food or water, depending on your latitude or altitude. There's avoiding nest predation. Or parasites as well, exploiting a seasonally available food supply, and longer days means more time to get that food, to find the food that you're looking for. Okay, there's also a corresponding reproductive success that goes with that as well. If you're a tropical nester, you might have 2 to 3 offspring in your nest. You're also going to you also have a higher nest predation and probably instance of parasitism as well. There's more predators and there's more parasites, and there's more of a threat to your young. So in addition to having a lower brood than temperate nesters who have 4 to 6 offspring, you're also probably still have as well a lower survival. Temperate nesters, besides having a higher number of offspring and a lower nest predation rate, you also have a shorter interval between successive broods than tropical nesters. It means you can get back into it quicker. And so sometimes some of these migrant birds, will get here and they've started their first brood maybe in April or May, and by early midsummer they might be on their second brood. It's important to get both of your broods fledged so they are ready. If you're a migrant, it's important to make sure that you start early enough on that second brood to give them a chance to fully develop and fledge out and have their adult wings and be ready to eat and get themselves set for that trip south. But there is a lot of value to overwintering in a place that has the foods you need, the tropics, but then coming up here where the days are longer and there's food available and there's less predators to worry about, so that you have more time each day to gather the food that you're going to feed to your youngsters. You can do it in a longer time, and over the course of that summer, ideally be more successful than you would be in a tropical ecosystem, which obviously you've been to and survived as well. But this gives you a chance to exploit those longer days, get more food, and take care of your young and be successful. So those food sources could include things that live underwater, fish or crayfish, any kind of aquatic food that may be trapped under ice or unavailable at other times of the year. Certainly insects is a big one. The insect count goes nearly to zero. There are species like kinglets, which are really, really tiny, and they actually come here for the winter, and they can exploit species of caterpillars and smaller bugs that are in the cracks and crevices of bark, or hiding out at the ends of twigs, and they're able to find those, but they're not flying. They're just hiding there. So these are birds, are really active. They're searching a lot, and then they're able to spot these very well camouflaged critters that are hiding in spaces that make them even harder to find. And then of course you've got birds that, like hummingbirds, that nectar. And if there's no flowers to nectar, and we don't have a lot of flowers in the winter either, then there's nothing for you to eat as well. And hummingbirds will eat some insects, but again, same thing. You don't have those insects in the winter. So, here's 3 very different food sources that are all dependent on, a warm season, and you're not going to find in the colder seasons around here. And again, Virginia's got a pretty temperate winter. I grew up on the Great Lakes. It's much colder there. It's certainly more severe, and that season for breeding is short. And you'll see, I've got some maps I'll show you a little later. Some of these birds go all the way up into Canada and even north, and so they've got much longer days, but that season is definitely short. So it's kind of a, it evens out a little bit there. But as far as you got these longer days, but you only have so many days because you got to get back because it's going to get colder sooner. But they are, finding a way to exploit these food sources during longer days. If you go somewhere like, say, Costa Rica, it's kind of a 12-hour day, 12 hours sun, 12 hours without sun. Whereas up here, we get much longer sunshine. Certainly north of here, we get much longer days of sunshine than 12 hours in the summer, and so that's something that's really working out for these migrants that go north. You can augment those food sources. Some of these animals, there's things you can put out. I mean, if you wanted to buy a whole bunch of I'm blanking on it. If you want to buy a whole bunch of beetle larvae that you can feed to them, great, but that's going to be expensive and it's not going to be very effective. Certainly you can put out the hummingbird feeders for as long as the hummingbirds show up, but eventually that food source is gone and they need to move somewhere. Some birds are able to switch their diet and hang around for most of the year because they can switch to other things to eat. Robins do eat a lot of critters in the leaf litter, but they will switch to fruits and nuts and other things that they're trying to find that they can find as well during the winter. But generally, if you have something that's really, really, really good to eat and it's here during the summer, you probably aren't going to have that same amount of luck in the winter. And that's what for a lot of these birds, if it's not something that's available year round, they tend to migrate to somewhere where they can find that food source. It's a really big piece of this. There we go. So here's Canada goose, and here is a map showing weekly through the year their relative abundance. So the darker the purple, the more Canada geese there are. The lighter the color, the less there are. And you can see they kind of stick around in this little band here, north to south between like I don't know, need to describe it. You can see the purple spots. But if you watch, I'm going to do it one more time. If you watch, you'll see them move northward as a population spread out throughout Canada, and they really get up in there. And so it's showing less of an amount of them in the summer, and then they all come back. And so we're kind of at that southern end. People, I think, often talk about Canada geese as migratory, but in our areas we tend to see them year round, less in the summer than in the winter. And we have, again, a really temperate climate that doesn't force them to move too far from here. And we've got these great lawns that we have in parks that we have in people's yards that provide them with food that they're welcome, that they're going to use. And so they don't go there. In fact, I bet you this abundance map would have looked different 30 or 40 years ago than it does now. You'd have probably seen more of a southward dip in that population, or at least more of a dip in the purple parts of it. And we're changing it. And also climate change is tending to make, in some cases, can make our winter actually less severe than it is. Oh, there we go. So when to leave? So what's the cue? How do they know? Do they set their clock? Do they have a calendar? Do they have a planner? Is this something that they've been thinking for years? Is it just instinct and they just know? Well, it tends to be really all about photo period. It's the length of day. As that photo period decreases from the maximum that you get in the middle of the summer, it triggers hormones and it tends to make birds start to get ready. It causes physiological changes. It causes them to be ready to migrate, and it really changes lots of things. There's a really neat name that the Germans came up with for something called movement anxiety. When you have a bird that's kept in an enclosure or cage, and it gets anxious in spring and fall because it's a migratory bird and they're trying to react to the stimulus that they're feeling. The German word is Zugunruhe. Zugunruhe. I'm sure I came not even close to pronouncing that correctly. But it's termed movement anxiety, and it's often noticed in these birds because they're reacting to these stimuli that tell them it's time to move. So they're either looking to move north if it's the spring, or they're looking to move south if it's the winter. If it's the fall. So again, waiting till everything looks like this is no good. Now, Canada geese and some of these other migratory birds might have Canada geese for sure do. Some other birds might as well have adaptations that help them survive this weather. You can survive this. A Canada goose can survive this cold winter weather all at once, but it's still got to find something to eat. And if the food's not there, it doesn't matter how well insulated their feathers are. It doesn't matter about the countercurrent circulation system they have going through their legs that help their scaly legs, which are not insulated by feathers, from freezing, even though they're standing directly on ice. All these things can help them survive winter, but if there's no food, there's still a problem, regardless of how well you can do with the weather. And so you don't want to wait till it gets like this. You want to make sure you're reacting to that photo period. And again, as that photo period drops after the summer solstice, that's a really big thing. There are some bird species that it's been shown that they respond to cues that are temperature. That's actually about temperature, and the birds will, at different spots, a population that will leave from different spots at different times because they achieve that weather cue that temperature cue that they need. But generally, it's pretty widely associated that most birds depend on the photo period as their cue to leave. One of the ways in which they discovered this was using this Emlyn funnel. And so what you've got here on the left, you see the bird, and the bird is in a funnel enclosure. The upper part of it has a wire screen so the bird can see the light and can see the photo period. And there's an ink pad underneath, and as the bird gets excited or tries to react to the cues it's getting, you can see on the circles here on the right where all of the activity of the bird is pointed to. It's either pointed north in the spring or south in the fall. So they had pretty demonstrative evidence that they're reacting to that photo period, and that's their cue for them to leave. Now, where to go? Okay, so you need to leave. You need to go somewhere. Where are you going to go? Around here, North America, we are very much used to a north-south migration. I feel like I read somewhere that this north, which is what we learn as migration in birds, and even that word, when we learn the word migration in school, it is. Are we back? Can everybody hear me?
Yes.
Can hear you, but
Yep.
don't.
All right, what's the last thing you heard me say?
I'm not seeing your slides, Ken.
No, I know. I got to find them. But what was the?
That was it. North-south migration.
North,
Yeah.
south.
That was north-south migration. Okay. All right, let's try this again. I never had this problem at home, but at work I always seem to drop the connection. North-south migration. This is when this is what we learn about. When we learn about migration, we learn about it's birds, and they migrate south in the winter, and they migrate north in the summer. They migrate south for the winter, they migrate north for the summer. Okay, that is a very North America centric view of migration. Okay, there are birds that react to different stimuli by migrating in different ways, not just north south and south north. And then obviously, if you're in South America, the birds arrive down there at a different, for their summer, and it's a different deal for them. So it's a different direction. But north-south migration is, if I remember correctly, because I feel like I read this somewhere, it is very much a Western Hemisphere phenomenon, that it's not that strong on the other continents. There's still some of it, but it's not quite the same. It's not as obvious as it is here. And this is a behavior that many birds have evolved, and some birds have evolved it separately. Some species have evolved it and then lost it and then did it again. And so it's really interesting. There's a lot of thought that a lot of the tropical birds were originally migrants that got there and figured out a way to make it work throughout the year. But let's take one that everybody's familiar with, Baltimore Oriole. If you look on the right here, this is a pretty traditional kind of abundance map or range map that you're going to see. So you got the red that shows where they're at when they're a breeding resident. This is they're the northern part of their range. This is where they're at in the summer. This is where they're breeding and having youngsters. The yellow is where they're a passage migrant. And what that means is you'll see them there during the migration, but you're probably not going to get them there in the summer or the winter. So they're just there in the spring and the fall as they're moving through. So they might be there for a couple days. They land, they refuel, and then they take off. And that's kind of the neat thing is in some of these states here, along this middle band of the U.S., they have a high number of birds that you're going to see in that state, but many of them are just in that middle in between. So this is a nicer map. So again, I really like eBird. I use eBird all the time when I go birding. But what I'm really impressed with is they've taken these, again, all this information and created these abundance maps. So this is a little more defined. It's a little more detailed, and it's through the observations of people from, birders from all over North America. And what they've done, again, just like that other one I showed you, is they've made an animation. So this is going to show where the Orioles are throughout the year. And what's really, really neat is, again, you're watching as it goes through here. You can see the timeline in the middle of in the right of the thing. I'm going to run it one more time. But what you can watch is the Orioles are hanging out here in Central and a little bit of Northern South America. And then when they get cued, they're going to zip around through Mexico into the panhandle of Texas and move and spread out into their northernmost range for the summer. And then when they leave, they're going to come back and they're going to go back the same way they came. You've just watched I don't know if anybody else noticed, there's a few little orange dots here and there where they might have found places, especially like, here, it looks like there's a little bit orange here around New York City, where, there's a few spots here in Florida where maybe they found a temperate oasis during the winter, or, it's warm enough in New York because it's a city and it's got, I didn't freeze. Sorry. I'm just trying to, heat island. It's got the heat island effect going on, and that might help them as well. But generally, this is what the migration of Baltimore Orioles looks like. Now, if we look at something like yellow-bellied sapsucker, again, here's the more traditional thing. What you'll find is in our region, here we are in the DC region, the yellow-bellied sapsucker, we're actually in their winter range, and they go north and then they come here in the winter. And so it's really relative about where you are. So it's actually a winter bird for us. And we have things like kinglets, like brown creepers that are up north in the summer and they come here in the winter. And then, of course, we certainly do have birds that are here in the summer and they're gone in the winter. So we can have different birds at different times of the year. It's not always the same thing. It's not the birds go up really, really far north and they go down really, really far south and vice versa. Now, this is an old school of thought, and this is, I think, one of the better descriptions, one of the better pictures I've seen of it. And they, this was, I think, something I remember learning. I had to learn in scouts in school like a long time ago, when I was doing that in like the 80s and 90s. And you have these 4 main migration flyways. And all these other areas, no birds fly ever, which of course is not true. Birds are migrating all across the US and all these different areas. But the idea of these 4 flyways is a really good way to point out how they may navigate. The green ones coming down the Pacific coast obviously are using the coast, and you can see one of the green bands kind of comes inward, and maybe they're hitting the western edge of the Rockies. So I don't know if that's an accurate description of that or not, but they're certainly coming in, and a lot of them are using that coast as the landmark for flying. And then you've got birds that are using this central migration flyway, and for many of those birds, especially as they come back up north, I remember going and watching the hawk watchers watch the hawks. It was really interesting to see them do that because they're so good at what they did. You're at the area where you're at the end of the Great Plains, and the Great Plains hit the foothills of the Rockies, and it's just, you're going straight across, and all of a sudden there's a ramp, and air is just shooting up. And so it's a great place to get thermals and get a lot of uplift and just cruise and use that as you're flying. That'll really, really help you out. And so you're not just doing all of that effort yourself. And many of these birds will wait, especially crossing bodies of water and things like that, for the right weather conditions to give them a boost, so they've got the wind at their back. In the Olympics, if you do that in the long jump, it's cheating. If you're a bird and you do that during migration, it's called smart, and it's a good way to survive. And then you get the Mississippi flyway, which I think should make, everybody should be like, oh yeah, the Mississippi River. It's so big, that they can see it up there, and that's a really good landmark. And then of course the Atlantic flyway, which is the Atlantic coast. And then so I showed you the Baltimore Oriole just so I could set you up to show you this one. They don't always use the same path. Okay, so this is a blackpoll warbler, and they're one of our later migrants. They're usually in mid to late May. So they're at the end of migration. And you can see they went across the islands and got into Florida and head back up and spread out. And then when they come down, whoop, don't even touch Florida. They go off of the Atlantic over in the Cape May, New Jersey, northern Chesapeake Bay area. I'm going to do that one more time so you can see it again. But here they are in northern South America, and then they just go right through the islands, barely stop, and they go into Florida. And again, they're all up in Canada and doing their thing, and then they come down, and then whoop, they zip out off of the Atlantic and go right directly across the Atlantic back to South America. And it's a pretty hefty distance for a small bird. You can see, this isn't somebody who's a giant. Their hand, that's a pretty average hand, and it's not a very big bird, and they make this this flight across the ocean, which is really, really impressive. Because of the way they go, we'll see them in the spring, but I feel like I almost always see more of them in the fall, or I usually do see them in the fall. Not a big fall birder. I tend to be a lot of other things going on in my life at that point. But I feel like blackpolls are the ones I see, and I have a feeling they're more abundant here in the fall than they are in the spring because of that switch in how they in their return trip. Oops, I don't do that again. Now there's also altitudinal migration. In North America, there's one or two types of grouse that do that. On the right is a Steller's jay. On the left is an American dipper. American dipper is a fantastic bird. Those big legs that actually dives under the water, uses those legs to hold on the rocks at the bottom, and searches for macroinvertebrates under the water. You can find some good video of that on YouTube if you're interested. But these are both birds that live in mountainous ecosystems, and they have an altitudinal migration in the winter, especially if it's harsh. They will move into more into lower altitudes and to get away from that winter weather, and then they'll go up further into the mountains during the summer when it's when the weather is better and it's not as cool, it's not as cold, and there's more food up there. So they'll do that. There are tropical species which will do the same thing. This is a violet saberwing, which is a type of hummingbird. There are hummingbirds and several other tropical species of birds that will move altitudinally in the tropics as well, and it could very much be a function of finding food. There's something in bloom, there's something in fruit, and so this altitudinal migration can be affected. It can also be affected by rain as well. And so they will do the altitudinal migration to get up and down a mountain at different times of year to exploit food sources. And wet and dry migration, as I mentioned earlier, there's also there's a value to following the water, especially if you're somewhere wet or you require a certain amount of wet. And this is the Jacobin or pied cuckoo. And there are ceremonies in India of this bird, and that it arrives, and it's really well thought of, and it's considered a harbinger of the wet season or the monsoon season. If I remember correctly, there's a traditional Indian story about this bird and how it has a mouth on top of its head, which could be just a misunderstanding of the feathers and how they're shaped to look like its mouth is open on the top of its head, and it's always seeking water, and so it's always trying to get more water, and that's why it comes to India during the monsoon season. And again, I think that could be similar to like when people look at a great horned owl and they see the two tufts of feathers that look like horns, but of course are not horns, they're just longer feathers. So this is a bird that hangs out. A lot of its species is over here in Africa, but they do cross through Arabia into India in time for the wet season. And so this is a slightly different kind of migration. You can see them all just pretty much go right across this Gulf, this Indian Ocean here into India. So it's a pretty good migration, and then they're back. So these are different kinds of migration. Now, how to get there? So it's all well and good. We know where they're going and we know when they're coming back, but how do they make that trip happen? Prior to migration, the gut and liver function increases. This is really important, especially if they're putting on weight. Okay, but as they get closer to their fat storage, they put some a lot of fat on. As they're starting to reach the capacity, or at least reach the amount that they need, the gut and liver begin to slow down, and then the heart, blood vessels, and flight muscles are all getting ready to prepare for this journey. And some protein is even donated from the gut and the liver. Now, you can put on lots of weight, you can make more stops. There's advantages and disadvantages to both. Obviously, if you put on lots of weight, it might impair your, at least at the beginning, you might be less of a good functional flyer than you were. If you make more stops, you open yourself up to more predation. You also open yourself up to, depending on places that may no longer be there, may not have the right kind of food for you. So there's different pros and cons to each of these strategies. This is a rufous hummingbird. They increase their weight by 60%. Okay, if I increase my weight by 60%, well, I'm not going to tell you. But it would be significant and it would not be pretty. But they use 16% of the calories in this process. They use 60% of those calories of the food they're going down just to convert the sugar that they're eating into fat. So there is, again, migration's a lot of work. There's a lot of preparation. There's a lot that they're going to put their body through. And then there's the molting. Some species molt before they leave a migration. Some species are going to molt after their arrival. The greater yellowlegs is one that molts, that literally molts in the middle of migrating. So it molts some, it does a partial molt, and then it'll fly. And sometimes you can even see them during migration where they're missing some of their primary feathers. And then they finish, excuse me, they finish replacing their feathers after they arrive. So that's an interesting strategy as well. So, and then you got to find your way there. So how are you going to find your way there? I talked about the flyways and the landmarks. That's really important when you're up there and you want to see. If you're a diurnal migrator, you're going to use the sun. That means not only is it helpful to see the sun, because cloudy days are going to mess it up a little bit, but also there's some understanding or calculation that's going on inside that bird's head for what time of the day it is. Because I think, as we all know, even though the sun's not moving, we're moving, but it appears that the sun's moving through our sky. And so where the sun is at 8 a.m. versus noon versus 4 p.m. is very different. And so being able to make adjustments as you're flying for that sun position is really, really important. And the same happens at night. If you're a bird that migrates at night, you're using the stars. And so it's also a matter of recognizing where those stars are. When I showed you those Emlyn funnels, they could do it with the night birds that migrate at night the same as they do with birds during the day. They were reacting to the sun or they were reacting to the stars, but they were able to show that was important for them either way. There is evidence that they can sense both infrasound and geomagnetic forces and respond to them. That they can sense in some way, and I don't think it's completely understood yet, the Earth's magnetic field, and they can use that to align themselves to migrate. So imagine if something happened to that, how tragic that could be for some of these bird species. And olfaction, which I think is really limited mostly right now to the homing pigeon, but there is some evidence to support that they use olfaction as well, or smelling, as well as a way to find your way there. And again, are you going at night? Are you going during the day? That second line really defines, what time of day you're going, one of those means of navigation. If you're a raptor that's going, you're probably, I think most raptors, I shouldn't say that. I know that many raptors will migrate during the day, so they're probably using the sun, but they're also depending on thermal updrafts to help push them along, which is really, really important as well. So picking your time and then your way of getting there is really important. And many of the songbirds, I'm pretty sure that the first time they go, that they're on their own. So how they make these choices, if that's hardwired in from, genetically or, instinctually, how that happens is really amazing. I think there's still a lot that's as much as we know about it, there's still a lot we simply don't know about how these birds make the trips. And it's important to get some sleep. This is a frigate bird, and they have shown, because they suspected for a long time that there are birds that sleep while they're flying. The question is, how do you show that? And there was a research research done, I don't know, within the last, I think 10 years or so, where they attached some sensors to these frigate birds and and released them, and they could track them, but they also tracked, if they were awake or not. And what they found was, in flight, frigate birds could actually go to sleep with one side of their brain. So half their brain was awake and making sure they were, they were flying, but half their brain was half their brain, excuse me, not their burn, half their brain was asleep. And so this was a way of resting. Now it's not, it's not like they're doing this for 8 hours like we would think. This sleep is very, very different. But they're getting in these little cat naps, these little few minutes of sleep while they're doing this. And it was always as they were ascending. They would never see the rest happen in the brain when they were on any kind of descent. It was only during ascent when they might take this little mini nap. And so all that, those little mini naps might add up to an hour for a day. And these birds could be on the wing for 2 months without touching land. So here's a bird that does not have any kind of oil on its wings. A lot of diving birds and ducks have, preen, they have oil that protect their wings and make them waterproof. This bird doesn't have that, and it's above the water the whole time. It's far from land, and it's doing this for months at a time where they're just soaring. And so taking these little mini naps helps them to rest. And again, they only do it when they're ascending, which I think is really smart, because if you're going down, it's probably not a good time to take a quick 60-second nap or however long it is. But over the course of the days, how they might only get an hour a day of sleep in, which is just I can't imagine. That's just crazy. But this is how they do it. I'm thinking one of my future deep dives is going to be sleep and how that works in different animals, because it's so different from what we would hope or want for. Let's look at some migration champions really quick. This is the bar-headed goose. I think this is the highest migrator. They've been observed at over 8,000 feet. This is a goose that's been observed over the Himalayas, even over Mount Everest, really, really high. They have a mutation in the gene that controls hemoglobin. It allows them to carry a greater concentration of oxygen than other geese, and that allows them to go higher than other geese can in the air. And I think, as far as we know, higher than most other species. And so this bird gets the win for that. They're not sure. They think the population is increasing. They're not sure. This is an Asian bird. Obviously, I talked about the Himalayas, but they're spread out over 900,000 square miles. And they're really, really spread out population. And again, obviously, if they're flying over the Himalayas, they're a high altitude. They're a bird that lives in high altitude lakes in these mountains. So there's probably not a lot of really good population data that they have on them, because they're inaccessible and it's hard to get to those spots. But we do know that they can fly very, very high because of that ability to hold oxygen in their blood. This is the bar-tailed godwit. In spring, it leaves New Zealand, visits Australia, Korea, and Russia. No, take a nice time of it. Take your time getting up there. Arrives in Alaska, and then in the fall they leave Alaska and they just fly straight to New Zealand. And these trips can be like 5,500 straight miles of flight. And over open ocean, again, just like the frigate bird. I'm sure that there's some mechanism for, semi-sleep while they're flying as well. And this is, if you're wondering what that looks like, this is a map of the route of several bar-tailed godwits between New Zealand, which is where the one end of the line's down here, and all the way up to Russia. See, somebody took a little break over here. But up to Russia and Japan. This doesn't even show them going on to Alaska. I mean, or coming back from Alaska all the way down to New Zealand. It's a tremendous amount of flying, but that's not even the longest flight. This is probably the longest flight without a break, is at 5,500. But the Arctic Tern, if you don't already know this, this is one they always talk about a lot, is the migration of the Arctic Tern. Excuse me, I need to take a drink. Pardon me. The Arctic Tern's migration route, they go from pole to pole. In this particular illustration, that's showing their southward migration from the North Pole to the South Pole. And it has been shown that some birds have been tracked, doing 66,000 miles in 1 year. So that's round trip between the poles. But where else are they visiting? Are they circling? There's a lot of movement for an individual. This isn't a population. This isn't, a flock of them. This is an individual bird, and they've been traveling over 66,000 miles in 1 year. To give you a little perspective on that. It's 238,000 miles, depending on the orbits and the position, blah, blah, blah. But it's 238,000 miles plus to get to the moon. If you look at 66, a 4-year-old Arctic tern with 4 journeys between the North and South Pole and back would have essentially flown the distance to the moon. It's just mind-boggling to me. That's how much they fly. It's really amazing what these birds do. They're small. They don't have the internet. They don't have books. They don't have anything that's physically telling them something they have to read up on and take a test and qualify to be a migrator. They do it. Their body reacts to these natural cues and it begins to change. It causes them to eat more, and then they do this. And their body does some pretty spectacular things along the way to ensure their safety. All these birds do this, was amazing. Now, the problem with migration, obviously, migration works or they wouldn't do that. But there are risks involved. There are problems that can be a big issue for birds. One of the biggest one, which should hopefully be really obvious to everybody, is if a bird migrates, it has now become dependent on not just one, but 2 habitats, 2 spaces, and the health of those habitats. So it's depending on where it's going to be for the summer. It's depending on where it's going to be for the winter or the other summer if you live in South America. So essentially, where are they going to be from March or April to September? And then where are they going to be from September back to March? These are 2 areas that now they become dependent on. And so if both of those habitats aren't healthy or aren't productive, aren't fruitful, don't have the food or the space or the habitat requirements they need, that's going to become a big problem. This is a nice little image of an American redstart, and it shows what the year looks like for them. If you start down the bottom left, they're migrating from South America up to North America. They have a breeding habitat that is, got longer days. There's food, there's less predators, so it can really influence their reproductive success. But then they're going to migrate back to the south because eventually it's going to be winter. The food they eat isn't going to be there. And so now, essentially, if you look at this bird is depending on these forests to be here in Central and South America in our winter. During our summer, it's depending on these forests to be up here in central, a little bit south, the southern states as well, but a lot of the central and more northern states in southern Canada. And if you read this little blurb here in the upper right, they also have stopover sites because they're not doing one continuous flight. So they're stopping at other places. So they're depending on the place they're coming from to be there when they go back. They're depending on the places they stop along the way for a snack, and then they're depending on the place they're going to still be there as well. Okay. And it's bigger than hoping that your hotel is going to be open so that you can get your bags in before 3 p.m. if you get there early, and hoping that truck stops still along the way to get gas and food. There's a lot of habitat need for these birds, even if it's just briefly for a small period of time. They're depending on this to be there. And with habitat encroachment the way it is here and today, it's a dicey proposition for a lot of these birds. Obviously, they don't know, but we know. I think that the poster bird, if you will, the poster bird for this kind of problem is the red knot, which is the bird pictured on the left here, the biggest bird in the image with the band on its leg. The red knot ties its northward migration to the spawning of the horseshoe crabs, who's on the right there. And so these horseshoe crabs are out there spawning in the shallows and releasing all these eggs, and the red knots, when they come through, they just feast on the eggs, and it helps give them the energy they need to finish their migration. So this stopover site is critical for this species. Well, a lot of people like to go to the beach, and one of the things you do when you're out there building on the beach and building a resort is you put up a wall so you don't have shifting sand, you don't have all this change on the coastline, and that inhibits the horseshoe crabs from getting into the area where they would normally go and lay their eggs. And so as you lose these egg laying areas for the horseshoe crabs, there's less spaces for the red knot to stop and feed on the way. I hate to be a bummer at the end of the presentation, I know, but the red knot is definitely a species of concern, and it might even be threatened or endangered. I know it's a pretty harsh reality for the bird, but with the loss of so many areas for these horseshoe crabs to mate, there's been a loss of this stopover habitat for the red knot, and it's critically imperiled that species. And then if you're interested in, I get two things I want to say with this image. If you're interested in migration and knowing when the birds arrive, it depending on the type of radar, it shows up all these little blue and green bursts. This is actually bird activity. This is a nice weather map showing that all these little mini bursts of migratory activity with birds. But also you can see there's a hurricane there. This is 2017, and as this hurricane moves up, you can see it's definitely going to have an impact on this bird migration as well, and it could turn them around and get them up in the wrong place. Or they might need to suddenly land and weather this out, and that can be a really tough time for a bird if you're spent, if you're tired, if you've used up a lot of your fat reserves, and then all this comes through and you got to wait for that and you're not able to get food. This can be a really big strain on your ability to survive the migration. Okay, migration is tough. 79% of tree swallows do not survive their first year. 4 out of 5 essentially will not. This is banded birds, so it's probably not an absolute number, but it's certainly an alarming number. Yet so many birds do this, and they do it in so many different ways. It's obviously worth the attempt. There is a set of conditions that makes this worthwhile for these birds to migrate, to go between these two places. And as long as it continues to work, the species are going to continue to do this. And it's fantastic. So there's a lot of things you can do. I think, without sounding like a broken record, you can plant native species. You can have a very bird-friendly yard with feeders, with areas for them to hide, with bird bass, even if it's just a stopover spot. Whenever we can work to protect areas along the edges of places like the Great Lake, areas along the rivers, areas along the coast where we can keep them as natural as possible, that's always going to help migratory birds. And then, and combating climate change in any way is a huge help as well. We're seeing the effects of climate change already. It's affecting the seasonality of foods. They're coming in, the foods are available earlier or later, and that's going to influence when the birds leave. If it affects temperature, that can also influence when the birds may stay or leave. It doesn't affect photoperiod, and so that's still, it's a very dependable method for these birds, but we might see some changes in populations as a result of these for climate change. For good or for bad, it's there. But for bad, it can also increase the severity of certain weather events, and that can definitely be an impact on birds that are already tired and weakened and struggling to get where they need to get. So these are all things to consider as we think about migratory birds. So I appreciate you all joining me. I appreciate your flexibility as I moved the program a little bit later to accommodate the earlier meeting. I'm going to get out of here. I'm going to check the chat and see if there's any questions. But if anybody has any questions, they're welcome to let me know. Oh, no questions. Couldn't have done that good a job. Does anybody have any questions? I see. Oops, hold on. Let me see if I can.
I don't know if it's a question or not, or how it relates to all this. My neighbor and I were sitting out, and both of us realized we haven't seen robins recently.
Okay.
What's with the robins all of a sudden?
What's with the robin? I don't know. I just saw one the other day. So they're out there. I think what happens at this time of year, because they've spread out and some of them do move north. If you remember the animation of the Canada goose, where they're here and there's a lot of them in the winter, and then they spread out north, and they're still here, but there's a lot more north of here. I think robins do that too. I think they tend to spread out more, and we get a little concentrated. We're kind of in that band where some of the birds that can handle some cold tend to be here year round, and I think robins are one of those birds where we'll start seeing a lot more of them here soon, because you're going to have to start seeing these migratory flocks move through, and you might have 60, 70, 80 robins suddenly popping by. But right now, it might still be hard to see robins occasionally. I've definitely seen them. I can't speak to why you haven't seen them where you are, but they're definitely out there.
Well, I have one that used to follow me around as I was gardening, but maybe I haven't been in the yard enough lately. So.
Well, and again, they don't live that long, and so I think that's kind of a neat experience that one would follow you and smart enough to realize that there's food coming when you're digging around in the garden.
Thank you.
Sure. Bernie, you got your hand up. Do you have a question?
Well, it's sort of a
Okay.
The red knot. And as you say, development is a problem, but they had several other problems that are very well known of it. One is they were doing okay until the people who make bait decided that horseshoe crabs make good bait.
Mm.
And so a lot of horseshoe crabs are being destroyed.
Yep.
Well, after a number of years, people realized that they had outlawed horseshoe crab. They outlawed that, fishing for horseshoe crabs is just a fish food. Of course, there are poachers, so that hasn't resolved. The other very more interesting thing is they use the horseshoe crab for a medical test.
Mhm.
And okay, well, it's so that of course was they put them back in the water after that, but a certain percentage don't make it. They die. Nobody really knows how much. Of course, the people who do it say, "Oh, not many of them do." And other people say a lot do. But what was really interesting now is that they've invented a synthetic substance. That's the same one. It's just produced by chemical means. Well, one or two companies are pushing it, have adopted it. The others have not. And here's a way that the companies that just like to do things the old way, they're actually working to deplete the population. Everyone knows it's endangered, but you can't somehow the government can't make them stop or to switch to the other one. The red knot has really big problems when you get things like this happening. It's not just development. A lot of that area where they go, it's not really developed. It's in the swamps and things like that. It's what man has done. Fishing the horseshoe crabs. There's so many of them, and just not switching to a synthetic chemical to do that toxicity test.
Yeah.
It's an interesting problem.
You're welcome, Holly. Thank you. Yeah, I don't know. I can't speak to that as much. I don't know much about it, but I do know there's a lot of pressures on the horseshoe crab. And then again, you've also got, and again, the red knots are going to feed on them. So that doesn't help the crab either, but that's also a circle around that it doesn't help the red knot. So it's tough, but I do know, I've been out there and you can see some of the places out there. And again, I get that people want to go into the beach and I get that people make a living and I understand that, but there's got to be ideally some way to kind of, for both things to commingle, because it has become a real problem for this bird. And I remember going to see it a couple years ago and spotting one and feeling really lucky because it might be one of those birds that's just not there when I'm older. That's one of those species I worry about. There's been a few species where I've been thinking I wish I could get out and see them because of this. And hopefully it doesn't happen, but that's the big problem. And again, like I said, it's really a good example of birds that might time their migration north or south to take advantage of a certain food source. And if that food source disappears, that becomes a big problem for that bird if there's not another way for it to get a food source.
It is a major concern for the red knot, though. The difficulty of enforcing the laws, and even though it's aware of it, or getting companies to do things a better, different way, it's a big problem. It's kind of.
I agree.
Absolutely agree. It's not as simple, even though you know what the problem is, and it's under recognized endangered species. It's just difficult to stop this whole kind of thing.
Yep. Thank you, Bernie. Anybody else have a question? Well, great. Well, thank you. If you joined me after the other meeting, I appreciate you jumping on here at the end. But I appreciate you all. Thank you. Like I said, I enjoy doing these and I continue to do them. I'm toying with the idea of sending out a survey to just see if anybody has some suggestions of topics or programs they would like, deep dive topics they would like. And just making sure that what I typically do, the 7 p.m. show, the time that still works for everybody. So thank you, everybody. Unless nobody has any other questions, I'll hang out for another 60 seconds. But if nobody has any questions, I'll probably end the program at this time. But thank you, everybody, for joining me. I appreciate seeing, I guess, all of your initials at least on the screen. And I hope you all have a very good evening.